going on, everyone? Welcome back to Better Biomed. Today, we're going to be taking a look at the heart of the operation here at the BC Group, and that is the machining and manufacturing process, along with the R&D process. We're going to meet the engineers. We're going to see how they make some of the custom parts that they do, and then we're going to see people assembling things. So we're going to go into some detail today. You're going to learn a little bit about manufacturing. Coming up next, right here on Better Biomed.
Hi everybody, I'm Lucio Simoni. I'm the engineering manager for BC Group. We've mentioned before that we like to do everything in-house, and we have all of our engineering all under one roof along with our manufacturing. So let's take a deep dive and see what that really means. So this is our engineering department, and mentioning that we do everything in-house, sometimes we're working on existing products. So we're maintaining and we're adding new features, adding new functions, redesigning for better technologies. So here we've got an example of our ESU 2350 and ESU 2400. Working on new software features, new hardware features. We can see the IPA 3400, some of the flow modules.
What are these guys right here?
So this is a new technology we're adding to the ESU market. With the 2350, we introduced surface mount resistors, and you can see there's probably a couple of thousand in there.
Wow. So these are all in like a network?
Right. So originally, the original gold standard for ESU testing were those large 250 watt gold Dale resistors, right?
Correct.
Well, those aren't very portable. It's hard to put that inside product and automate. So with the ESU 2400, we went through and used wire wound and non-inductive wire wound resistors inside the load bank. That got it smaller. You didn't need all of those multiple parts to carry around. And then when we went to the 2350, we tried to go with surface mount parts. So that allowed us to get even smaller and lighter. And now we're taking that technology that we know works with the 2350, and we're putting it into the 2400s. So this is an example of a replacement for a wire wound resistor. So we've got a whole lot of parts here, all of these surface mount resistors that we put in place of that wire wound. And now we can actually have more power dissipation in these than in the same footprint than we could with the wire wound resistor. And being surface mount resistors, they're even more non-inductive than non-inductive wire wound.
Interesting. So you guys have really large cooling fans in there, and because you have a lot of clearance, because the wire wound creates a lot of, I would imagine, vortices where air would not flow over the boards evenly. And now I'm looking at very smooth, very evenly laid out boards. So you probably have better heat dissipation.
Well, and we have a pretty good algorithm in there too. So we have 8 temperature sensors that measure the output temperature, the airstream of the load. So when we measure power, we're continuously measuring the applied signal and power from the generator. So as soon as power is applied, we know that we need to kick up those fans and make them run faster, get more airflow. And then also, if it warms up just due to temperature, we can also increase the fan speed and decrease that temperature. The other benefit that we have is we can even detect a stalled fan if it gets blocked or occluded or fails. We can detect that and present an error to the user.
What is this guy right here?
So that is the inside of an IPA 3900 FM flow module.
Okay.
And that's what actually runs the IPA 3400.
So that's the same as these modules over here?
Those are the removable modules. Yep,
okay.
That's correct. And so what we found with our service department, we service all brands and manufacturers of infusion pump testers. What we saw in the market is there's 4-channel devices that a lot of people wait until 2, 3, or 4 channels fail, and then they would send in their 4-channel unit for service.
Right.
Well, now they're down that whole time. And what we found is if we put all of the calibration, all of the functionality into one module and make it removable, now if they need to do calibration, they send in that one channel.
So the calibration data is stored on like a digital table that's on that board that's
That's
in there?
correct. Yep. And that's what's behind that there.
Is
That's
that
the
the board?
Yep, that's
Oh
the
wow.
guts. That's the smarts of the
It looks
flow
like
module.
we got 2 pistons. So
Yep, those are 2 syringes. And actually, what we get with that is one is always filling and one is always draining.
okay.
So when it runs, it actually cleans itself as it moves the syringes back and forth.
Okay. Yeah, because they're constantly wiping the cylinder walls.
Exactly.
Wow. That's crazy.
Now, we still do have a drain mode because you wouldn't want to ship that unit by air if it had water in it.
Of
So,
course.
before you do transportation or long-term storage, we have a drain function to get out any remaining fluid that's in there.
Oh, that's so cool. Oh, and look at the detail. So these little parts right here, I know we'll probably get to this later, but do you actually manufacture all these little components right here, or do you like outsource these?
So we do have a machine shop in house. Again, one-stop shop.
Yeah.
So we can do the aluminum. We can do plastics. The ceramics we outsource because manufacturing ceramics, it's a very niche market, and it takes a lot more equipment than even what we have here to be able to do that.
That's crazy. That's amazing. Also, I see some more machined aluminum right there. That's beautiful. Well, thanks, man. Didn't mean to invade your space, but you do some cool stuff, though.
On this side, we've got an example of not only do we design products to sell to the biomeds, but we also develop products for helping with calibration and automation. So this particular test fixture here is for testing the ultrasound leakage tester, the ULT 2020 and the 7193 model.
So this is your own in-house calibration
Right.
system.
So
Okay.
because we're measuring such small leakages, 5 microamps and below,
Yeah.
it's very sensitive to any changes in the load, and so we have to have very special ceramic loads in there to make sure that we get a stable and consistent leakage
Okay.
calibration and reading.
That's so cool. It doesn't look like something that would be an in-house product because normally those would be like a prototype. This looks like a finished product. It looks beautiful.
Well, and that's also some of the benefit of having everything in-house. If we need a custom overlay for this, we don't have to go out and outsource that. We can print those in-house and make exactly what we need
Right.
for prototyping and small volume
You'd have
quantities.
a minimum quantity of order,
That's right. Yep.
Wow. Okay, so you could do one-off things if you wanted to. So even your prototypes look like they're finished goods.
Right. So this is where we're doing our mobile device development. So this is our MyBC Mobile. So we've got software that we're doing for Apple and Android. Of course, that means that now we have to double our testing and double our development hardware because we have to test on both platforms. But again, if half of the market uses Apple and half of the market uses Android, why tell the biomeds you have to have one or the other?
Right.
Pick your device and we'll work with it. And that's our philosophy kind of with everything.
That's cool. It looks like we have a plastic circuit board.
Right. So if we're going to design a new product like we're doing here, the first thing we want to do before we even make any circuit boards is make sure that, is it going to fit in the box? Now we can do everything with CAD with our software design. We can look at it on the computer screen. We can, print it on paper, but nothing's the same as actually holding that board in your hand and you can look and you see,
Yeah.
do I actually have any clearance issues? Are the parts going to fit? So this helps save and reduce cost and iterations on circuit board designs. And it allows us to make sure that, when we do finally go and order parts, we know the circuit boards are going to fit in our enclosure.
You have different revisions of the same board?
That's correct. Yeah. So as we're doing prototyping, I don't think we've ever shipped a Rev Zero circuit board, to be honest. We always have a initial design concept and evaluation, and we always find problems as we go. Some part doesn't work like it's supposed to, or we have to revise circuits. And so we'll do those revisions in house and make sure everything's working properly before we ever go to the field.
Right. So you're in a constant.
Practically identical.
Yeah, you're trying to decrease the quantity of components, but at the same time decrease the form factor, make it more portable.
Yep. If
That's
you want
right.
to see another rev of that one, this guy right here is the Rev 2 of that microboard.
Oh, those are beautiful.
Obviously, they haven't been assembled yet, but
Yeah,
these
look
are
at
the
the
boards.
detail.
Yeah, so doing everything in-house, we'll design the circuit boards, we'll design the layout, the panelization, but we don't actually manufacture the raw circuit boards here. But we will take a look in production here in a little bit, and we'll show how we actually put the parts on the boards with the SMT assembly line.
Very cool.
And you've got a board there
Look at all the detail on those PCBs
and a stencil.
and a stencil. Excellent. That's so cool. Usually people don't get to see um, the whole process of designing a circuit board. This is so cool. They got breadboard set up.
Yep, that way we can test and
You can see
evaluate,
live trace on the oscilloscope for what's going on.
make sure everything's going to work before we ever.
That's so cool. Thanks, man.
All right, so we've got new product development, we've got product revisions. Here's also more examples of new product development. You know, we'll use signal generators, we'll use power supplies, oscilloscopes, a lot of CAD and software design on the computer. But when it all comes down to it, you've got to build the board and test the parts. So,
Excellent. One of the coolest jobs ever. It's creating new things.
yep. And we also do in-house software development, our web software for interfacing with MyBC Mobile and integrating our test sequences and test data, integrating that with CMMS systems. And actually, we can take your test data, you can create a test sequence, assign that to a work order, run the test, gather your data with your mobile device, and then upload that directly into your CMMS system. We can fill out the work order, apply the labor and materials and cost to that, and even close your work order for you and automate that process. So all of that development is all done here in our team.
So what if I'm gonna throw you a curveball here. What if you notice a certain trend with your existing fleet? Or let's say you notice something with a competitor's device and you want to make a change on your own product. So everything seems to be right here in this room. Are you able to do that, and how quickly would that happen?
Absolutely, and that's the benefit of having that in-house. So we don't have to outsource our firmware. We don't have to outsource our hardware design. A prime example is a new technology that came out with defibrillators. So they added pulsed biphasic to the output of the defibrillator. It used to be monophasic, and then they went biphasic, and then this concept of pulsed biphasic. And so what we can do, even if you had the first defibrillator analyzer out there, we can add those features by doing a firmware update. And then all you have to do, you've got the same hardware that you've always had. We're not going to obsolete it and say you need to buy a new model to get this new feature. All you have to do is a software update. It's available for free on our website. You do that software update, and now you have pulse biphasic function for the product you already own.
That's wild. That's
And the
awesome
same
at the same
same
time.
thing we've done with Bluetooth. So a lot of our older designs, you know, they didn't have Bluetooth 5-10 years ago. So what we've done is we've designed modules that you can plug into an external serial port, and now you can add Bluetooth to your existing product.
Wow. And that goes back like along as far as you can remember on the BC line.
That's right.
That's crazy because usually you have to buy a new product in order to get that kind of added functionality.
Right.
Very cool. I like some of the older test equipment. Guys, everybody on my channel knows I love older stuff. I actually think I used to have that exact oscilloscope. I love the Decade and the DC power supply. I dig it, along with
Yeah.
the newer ones.
Just because they're old doesn't mean it doesn't work.
Oh, for sure. For sure.
Yep.
That's
and
cool.
So we'll also design test fixtures for in-house use to help ease with our assembly process. And so again, when we say we do everything in-house, we really do everything as far as designing new products, maintaining existing products. The whole idea is to make sure that you guys aren't out. When you need a product, we can manufacture it.
So you guys also design your own in-house testing structures for doing automated testing on like your electrical safety analyzers, and your in-house team, they also develop special products for you guys so that you guys can standardize your testing and make it more efficient. Because you're also, it looks like you're in a constant phase of product improvement and process improvement.
That's right. So yeah, it's never a dull moment here in our engineering team, and we never know what we're going to be working on from one day to the next, whether it's new products or helping out manufacturing. Again, improving those processes and then bringing that savings to you by being able to make them more efficiently.
Excellent. Very cool. All right, guys. Thank you all for your time. I appreciate y'all.
So now we're going to look at the complete process of how do we actually manufacture the circuit boards. This machine here is loading in the raw circuit boards here. These don't have any components on them. So it automatically feeds in the board. It verifies that the board's in place and in the correct position.
So what if somebody loads these in backwards? It'll know if they're
It'll
loaded backwards.
know that because there's special alignment markers on the circuit board, and if it doesn't see those, then it'll create an error.
Very cool.
It'll stop the process. So then this machine is applying the solder paste. Again, looking at those the screens for the solder paste. There's a little squeegee in there, and it will apply the solder paste exactly where it needs to on each of those pads.
So it does it all in one swipe?
Correct.
Okay. Look how complex these machines are, guys. And they actually can operate at an amazing speed. So not only can these things do it faster, but you guys have various levels of quality control to make sure each step of the way is good to go before it moves to the next step.
Right. And it paused here for a second before it did the squeegee.
Right.
It didn't detect the fiducial where it needed it, so we had to train it and move it so that it knew exactly where the circuit board was.
Oh, wow.
And so each of these has doors for inspection.
Yeah.
So we can, all along the way, we can look at the board and make sure, is the solder paste where it needs to be?
So this one here already's got solder paste on it.
Right. So that's ready to go into the pick and place machine.
Looks extremely consistent from pad to pad.
And that's the benefit of having the automation. So this next machine is actually going to take all the parts and put them onto the board.
Ooh, there we go. Now take a look at all these. Now they're all different shapes and sizes.
That's right.
It's incredible that the machine can take components that are all different shapes and sizes and place them. And it places them quickly, like at an insane speed. Oh, I didn't know that they can also do connectors.
Yep.
How the heck would it grab a connector?
Well, it's got a little vacuum pickup head. There's 6 of them actually. So if you can get in there, it's picking up 6 parts at a time. And
Wow.
It takes a photograph of it to make sure that it gets the alignment.
So that's the flash that we see?
That's the flash that you see, yep.
But it looks like it's, I mean, if it's taking a picture, it's doing it while it's transitioning across.
And it's
That's so
actually
fast.
taking 6 pictures there because all 6 heads are picking up a component.
Oh, wow.
And
Okay.
so every single head is getting adjusted for rotation. It's verifying the part is actually there. It wasn't dropped or missed.
And these are the reels that you're talking about, that some of them have to be in a enclosed environment until they're ready for use.
That's correct, yep. For parts like headers and resistors, they're not sensitive to moisture. But when you get into integrated circuits like your microcontrollers, they have issues with humidity, to where if they absorb any moisture, because they're not perfectly sealed, the
Yeah.
component. So if that package absorbs any humidity, once it goes through the reflow oven, it'll boil and actually destroy itself inside. You may
Wow.
never be able to see it externally, but the part won't work.
So I got to ask you another curveball question. What about ESD? Because these machines are flying as fast as they can.
That's correct. And you see we don't have ESD wrist straps
Yeah.
as we're handling circuit boards. So this is actually a very special facility underneath the floor, built into the concrete, and this is a conductive epoxy floor. This whole surface is ESD protected, and actually we test it every year with our Cal lab and verify that the integrity of that ESD protection is intact.
Wow.
Again, it goes back to the quality system and making sure that your processes are working like they should.
Right. There's other things that I always take notice of. Is like air vents and stuff are normally dirty. This is an extremely clean environment. So this is very cool. Usually people don't get to like go behind the scenes and see this kind of stuff.
So once
Oh,
the
look at
board
that.
comes out, then we have a manual inspection station with magnification.
Is this a camera or a
That's a
microscope?
camera. So yeah, if you scroll up a little bit, so then now you can get a zoom in of each of those parts and make sure that is it placed properly. Are there any parts missing? Again, this is where we might add components manually as well.
Okay. So what if something's missing? What if there's a problem here? Does it alert you or?
At this point, it's a manual inspection. Now we have another machine that will inspect every solder joint, every component, and it will tell you if there's something missing or a solder bridge.
Look at this beast. This is crazy.
So this is the actual, it's called a reflow oven. And so there's multiple zones in here, and we custom program the profile for each circuit board so that it properly brings it up to temperature at just the right rate, and it quickly solders all the components, melts all the solder paste that's on the board, and then it cools it back down.
So it only stays at temperature for just a moment, and then it starts cooling back down almost immediately. That's cool. This is massive. What a beast. You can see everything's got ventilation ducts, so it's not vented to atmosphere in the room. That's cool. Look at all these resistor networks. So these will obviously be broken out into individual little cards.
That's right.
And are these the same size as the wire round resistor for length?
That's right. Yep. So these tabs match the exact size. And so you can actually take one of the wire round resistors out of the circuit board and put this in its place. And now you have a SMC load bank.
But I mean, the density that you can have of cards versus wire wounds is much higher.
That's right. And actually we have more power capacity, more dissipation capacity in these because we're distributing it again across more parts, right? So we may have a 60 watt resistor in the wire round. These we have 80 resistors on there, so it's really an 80 watt load.
Right.
So same size, more power.
Interesting. Just electrical theory in a nutshell.
Now this is
look at this.
the next phase of the process. This is actually a safety analyzer board that we're looking at here. So you can imagine these relays, that's not a surface mount part.
Right.
So this station here allows us to add components that are maybe through hole, some of your headers, the potentiometers.
So this is the same board.
That's the same board as this one, yep. So this one has all the SMT parts on it, and then over here we've added all of the through hole.
That would be a nightmare for placement.
Oh, could you imagine hand soldering all that through hole?
Oh, yeah.
So what we do is here we put in the parts into the raw circuit board, and this next stage of the system will be a selective solder. So the selective solder is actually a solder pot that we can program it and tell it exactly which pins to solder on the circuit board.
So the circuit board's up here, and the pot comes up from the underside and solders individually. That's crazy.
So we can actually see it on the video here.
Let's take
It's
a look at the underside of the board. So what they're saying is it will come up and hit very specific points, and that affixes so that they never have to invert the board because that would dislodge them. Oh, beautiful.
That's you can actually see the path and the soldering there.
So
on all
the solder's constantly flowing.
That's right. It's a completely molten pot, and there's a pump in there. You can control the pump speed to see how high you want the wave.
Oh, look at this. You
That's
even
the
have
path
a
that
path.
it follows. That's right.
Oh, that's so cool. So let's say, because I mean, in this part of the process, there's a lot of room for error. After it's done with the oven, and after you're done with the large components and the selective soldering, how do you know for sure? Because I mean, look at how many components are on there.
Yeah, and how many solder joints,
How
right?
would you know that they're all good? I mean, I'm really curious because you got a lot of points of failure. How would you know for QC purposes that that board is good to go?
Yes, there is. Yeah, there's a lot of potential points of failure.
Right.
But let's take a look at another machine that we have over here.
Okay.
And this is an AOI machine, automatic optical inspection.
Okay.
So very similar to these machines, it's a conveyor belt driven system. So we have our cartridges of boards. We can load those in. And again, adding automation to the process, it can pull in the circuit board from a cartridge, do an inspection on that board, and
Oh,
it's
cool.
actually taking a picture of every single component, every solder joint, every label, and it's making sure that the part is, one, present, it's not rotated. It can measure the solder on every solder joint. It'll tell you if there's components that did not get soldered.
Right. Oh,
It'll
cool.
verify all the part numbers on all the
So
parts.
they come in here one by one. And what's interesting is you guys have it down. So it's not actually one board. You got 4 boards on there.
Yeah,
So 4 different separate PCBs, but they're inspected as a single PCB. And I see barcodes and stuff on there. So that means that you can track, like even if there is a problem, you can track it down to a single
panel
single
on a single
run.
board. Yep.
Oh, that's cool. Because you might have a common problem. Wow. Oh, so cool.
So here it's running now. It's actually taking pictures of the components, and you can see it uses different color of light. So to get different angles, lighting is always a problem, I'm sure, as you know, with recording video. Lighting is always a problem with video and cameras. So it uses multiple different colors, and it's actually measuring. These are all the points that it's checking, making sure the part is there. Is there enough solder? There's no solder bridge. There's no missing solder.
That's crazy. And you have records of every single one of
Every
these.
single board, every single record. That's right. So you imagine that's a lot of data.
Oh yeah. I mean, so here's something for you. You guys, obviously, you're manufacturing things, so you're ISO 13485.
That's correct.
Okay.
Which is a medical device manufacturer.
And what about 9001?
9001 as well.
Okay. Wow.
So, and what that really means is we have processes in place for everything we do is a controlled process. It's documented, it's verified, and then it's also audited every year.
That's
so
very
we
cool.
have inspections for 13 and 45, just the accreditation, and then we also have the FDA that comes in and inspects our processes as well.
That's amazing. And I see that you also have hand processes, even on top of like all the automated process. There's still a lot of things that have to be done manually.
That's right. And so we have those manual soldering stations here.
Oh.
Again, there's just some things that the machines can't do. You need a human touch.
Right.
And so we have a lot of very skilled people who are able to do that for us.
Look at how large some of these components are that you guys have to put in. Oh, look at this.
That's our that's our temperature sensor board for the ESUs.
Oh,
Again,
really?
these are mounted in the back of the circuit board in the airstream, and that's how we can make sure that as the air flows across all of these wire wound or surface mount loads, we can make sure that it's not overheated.
Interesting. And you guys custom design your own power supplies and stuff too?
That's correct. That's a isolation power supply that's used in the ESUs.
Oh, how cool is that? So in case you guys ever wondered what's inside your devices, there you have it. Fascinating.
So you see a lot of microscopes.
Yeah, it would take a lot of attention to detail
That's right.
to be able to do this kind of stuff. It's fascinating. I see you have a lot of people over here assembling cables.
That's right. A lot of people like to outsource their cable manufacturing. We have a different philosophy. Again, do everything under one roof. So we'll do all of our main product sub-assemblies. We'll do cable assemblies. All of that done in-house. same kind of thing. You know, if we need something quickly, we can, you know, rearrange our schedule and produce as many as we need to. Case in point, we had an order for 400 pressure meters one time, and you can imagine, you know, that's not a standard delivery for us,
Who's
right?
going to keep 400 on the shelf someplace?
So what we're able to do is, you know, schedule the SMT line, schedule the production facilities, so that we can get that large order out to the customer as they need to.
That's crazy. So most companies out there, even the biggest ones that you all can think of, most companies will outsource their cabling to China, Taiwan, etc. But you have a wire build station here,
That's right.
and those are pinning machines for like Molex connectors. I mean, you guys can see
Well, and
how that
the
process
benefit
might
of
be.
having that in house is we can do the inspections. We know for sure that everything is built to our standards. We know exactly what materials are used, so there's no counterfeit parts.
And you don't have any minimum build quantity.
That's correct.
So, I mean, if you needed a custom cable for a custom solution, or let's say you have a device, because we've seen in some of your other videos that you have some devices that you don't sell that many of them, but your customers are still buying them. So you're not gonna, you know, have like 100 on your build quantity because you're only gonna sell 20 of them.
That's right.
That's crazy.
But we can still offer that benefit to the customer.
Look at the quantity of different cables they have, different gauges, different conductor counts. Is it thermocouple wire? Almost looks like thermocouple wire.
We do have some thermocouple wire, yes. That's right. J and K.
That's so cool. And you obviously have build sheets and stuff for what needs to happen for every single cable that you produce.
That's right. Everything is documented. Everything has a process.
Oh, that's
It's all part
incredible.
of the quality system.
Look at these jigs. So did you guys have to custom make these jigs?
That one we purchased. That's,
Okay.
Yep,
I've never seen anything even like that before. It's pneumatic, of course.
that's right.
That's so cool. And what are these wiring jigs right here?
Those look like they're for safety analyzers or ULTs.
Okay. That is so cool. Look at this piece.
Right. So once you build the cable, that's only half of it. Again, part of the quality system is we're going to plug that cable in, and again, this is part of our fun engineering task is to provide something that production can use to do 100% testing of everything that we make. So we can put it on this test rig, turn on each switch, and make sure that one, we don't have any wires crossed.
Okay.
It's wired correctly, and every connection is a true continuity test.
That's wild. I've always wanted to make something like that, and I've done it off camera for testing, you know, certain cables on that are known failure points on medical devices. But that's cool to see one here for your own custom cables. That's very neat stuff, guys.
Yeah, and that's part of, you know, I mentioned a little bit, you know, 100% testing. That's part of our quality system. So we'll do testing all along every phase of manufacturing, from the circuit board itself, inspection of the solder and components. We'll do inspection of the cable assemblies, inspection of the sub-assemblies, but we're not done. You know, we still have to build the product. So once we assemble the final product and do the calibration, we do 100% inspection of every function, every input, every output, every analog circuit. We make sure that they're all calibrated and functioning properly before it ever goes to inventory. So part of our 100% inspection is, this is our area here where we do the final assembly. We'll take all of those sub-assemblies and cable harnesses that were built in the other areas. We'll bring them together here, and we'll do batch builds of each of our products. And this is where we do the adjustment, the calibration, and verification that everything's working properly.
I've got a question for you. Something that may be irrelevant to the topic of this video, but okay, these are defib analyzers. Notice how these are banana jacks and these are banana jacks. You know what I'm going to say before I even say it. So what if somebody does a shock on your pacer load there and you blow it up?
Well, so we used to get this product manufactured for us by another company. We private labeled it from Metron, and that was the DA 2003.
Okay.
And again, part of our service is we have to, repair and maintain those products. And we would keep getting complaints, and we would find failures that the customer, the Biomed, would accidentally defibrillate into the pacer input. And so when we designed our own product, we said there's got to be a better way. We've got to provide a better service to the Biomed rather than having to repair it every time they accidentally connected to the wrong port. And so what we did was we designed an input protection circuit so that even if you were to accidentally defibrillate into the pacer input, you're not going to destroy that whole load bank for the pacer circuit.
Yeah, I would think that that's normally the Achilles heel, but that's cool. Very cool. I just figured I'd throw that in there for you. Interesting. So when devices are assembled, they come over here, and this is where you're going to test them out?
That's right. So every product is 100% tested to make sure that when we're testing defibrillator analyzers, we'll actually use a defibrillator. We'll make sure that we're testing it the same way that you're going to be using it. Same thing with finger sims. Every product that we make gets 100% functional testing.
Very cool.
So you'll see patient monitors around, you'll see defibrillators. All of that equipment is here, electrosurgical generators.
Yeah. Wow, look at these test benches, guys.
These are safety analyzer test stations. So we've got our large power loads down here.
Oh, yeah.
We measure up to 20 amps.
You got current transformers.
That's right. We have to make sure that we can read 20 amps.
Oh, what are these? Oh, moisture monitors.
Those are moisture monitors, right? So we'll do burn-in testing. We'll make sure that they run for at least 8 hours.
Oh, so the ohmic line. Okay, gotcha. Very cool. It's fascinating to see this stuff as it's being assembled and tested. And then, okay, so let's say that we're done with testing. Where do they go from here?
So then they go to the next point of inspection. Again, it's all quality control.
Yeah,
and
I'm seeing a trend here.
yeah, everything gets inspected. So then we bring all the products together and we prepare them for packaging. And this is where they go through another level of inspection. So every product has at least 3 people. There's 3 sets of eyes. The person doing the manufacturing, the person doing the calibration, we have verification, and then they come over here, they all come together. We verify that the calibration sticker is correct, the serial number is correct.
And you also combine it with the service reports.
And the calibration certificate.
Wow.
Accessories, user manual. This is where everything comes together and it goes into the box to be put on the shelf.
They're itemized for all the accessory kits and everything. Wow, that's so cool. I've got yet another curveball I'm going to throw to you. All right, so what if a product needs a revision or improvement? And I kind of pointed out to it, but what's going on with the orange plugs?
So that's a great point. What we like to do is get the product ready as much as possible for the end user. So we'll actually store these in inventory with the batteries installed. Now, if the battery's installed and it sits on the shelf for 6 months before you get it, that battery is constantly draining, even though it's a little bit. We don't like that. So what we've done is we've designed a plug that we manufacture in-house, and this disconnects the battery internally. So even if it accidentally gets pressed or pushed on the power button, it's not going to turn on until you remove the plug.
So if somebody's so excited to get their new toy and they rip the tags off, which I mean we do for T-shirts and everything else, right? So why wouldn't you just grab the tag and rip it off? And meanwhile, because I would think that it would be like a port protector or something. You see a piece of plastic hanging out of your device, you think, oh, until I need that port, I'm just going to leave it there, right?
Right. So if we take the battery out, then we have to find a place to put it. We have to have a storage compartment for it. And then it's just easier. You've already got a battery compartment, install the battery, the product's ready to go, but we don't want to drain that battery
Right.
for the end user. So
what about product improvements? So let's say you've got an excellent idea, or let's say you've noticed a trend.
okay.
Let's talk about product improvements, because you guys are obviously in constant level of R&D.
That's it's a good point. So we've been talking about the quality system on our inspections and all that.
Yeah.
We have a whole quality department that what they do is they review complaints for the field, issues that may come up, warranty repairs, that sort of thing.
Do you have any examples?
Well, yeah, a good example of that is a very similar product to what we have with the ULT. We've got one over here actually. So this is these are pressure meters,
Okay.
and um, a lot of times when we first designed this product, we picked out a sensor. The manufacturer says it's compatible with fluids. It's not going to damage the sensor. It's got a seal. And so what we found is that a lot of customers will take these and they'll test their infusion pump for occlusion pressure, which that's a test that we
Okay.
need to do.
Of course.
And the manufacturer of the sensor says, yes, it's compatible with fluids. So the problem though is that if fluids are left on the sensor and it's in contact with that fluid over time, it can affect that reading,
Of course.
right? So over time, we would have people say that my unit won't read accurately anymore, it won't read 0, that sort of thing. They send it to us and we test it, it works fine, right? Because in the time that they've shipped it to us, it's
It
dried,
dried out, right?
It dried out. And so now it's not wet anymore and it didn't damage the sensor like
Wow.
they said.
So now the customer's saying it's got a problem that you say, no, it really doesn't.
So our quality department looks at those complaints and those, those issues and they say, there's got to be a better way, right? So we don't have to outsource that to anyone else. We bring that inside. Anyone in the company can raise an issue. They can issue an engineering change request. So again, that's part of our quality system. Anyone can say, hey, I need this to be investigated because I think it's a problem.
Okay.
So quality, they come to us and they say, there's got to be some better way that we can keep from these units going back and forth. And so what we found is this, this is a hydrophobic filter here.
Okay.
Now, hydrophobic just means that water cannot pass this membrane.
So air pressure can pass through.
Air
Okay.
goes through just fine. So what we found is that if we add these protectors to the input of the circuit, that we don't have to worry about water getting onto the sensor and affecting your readings. So
Okay.
this is a good example of feedback from the field, feedback from quality, saying, how can we make this product better and provide a better solution to the biomeds?
Very cool. Easy solution too. Okay, earlier we talked about how you guys actually can create parts that don't really exist because we've seen some machined aluminum, some machined plastics, and you guys say that you do a lot of stuff in-house. So what does that look like for you guys?
Right, so we mentioned the machine shop that we have with the CNC machines and the Swiss lathe. So a lot of what that does is it allows us to buy a standard enclosure. We can add the holes to the enclosure and make our product. You're not going to find this ECG snap anywhere off the shelf anywhere. So our engineering team can design this part and the specifications, and we can manufacture it here in-house. But the other thing we can do, again, to go into a little more specific, let's say, for example, we need to simulate non-invasive blood pressure. How
Okay.
would we do that?
I don't know.
So in our case, this is our pressure engine. And so we machine a piston that's inside this block and this stepper motor. And so we can machine this block in-house. We've designed that to be the correct volume and
So because it's on a stepper, it knows how much it's pushing.
exactly.
Oh, okay, cool.
That also allows us to do custom configurations for neonatal, for different types of, we can simulate different types of blood pressure waveforms because we have absolute control over that stepper motor and the piston.
Very cool. I see how you do it. I know every manufacturer kind of does it differently because you have volume and frequency that
Right.
you have to. Okay. Very cool. And pressure. Very neat. I've never looked inside one of these before. Well, now you know. It's a little piston that does all the work. Very cool. So you machine the aluminum and everything
That's
here.
right. We'll do the design and the manufacturing in-house and then assembly as well.
So you have a team of people that actually create the part in 3D software.
Mhm.
And then the software, then the completed model comes back here and you have somebody that puts the code in for the machine and knows how to cut that part out of a raw material.
That's right.
That's fascinating. Okay, so inside the BC Group items, since it's medical, you're going to have extremely tight tolerances, and you have a huge amount of items that you produce out there. So I'm guessing you might not create a huge amount of them, and I'm guessing that's why you have your own machine shop. But this would also be very expensive.
It definitely is. And so here in our machine shop, we have the ability And you know, we kind of put this in place with the mindset of not just what do we need to make today, but might we need to make next year or 5 years from now, right? So today we may be making very small blocks for NIVPs, but tomorrow we may need to make a much bigger part. So we tend to go into overkill mode when it comes to equipment and facilities. And not only do we only make products for ourselves, but for example, here we're making spray guns that we've been making for decades now for the semiconductor manufacturing process.
So these spray solvent or something, or
That's
acid?
right. So when you're processing silicon wafers, you have to clean them with deionized water. We have to make sure that all of the materials that touch any of the fluids are clean and not able to be.
They're not reactive, right?
They're not reactive.
Okay.
Right.
So this would be, oh, you got a serial number that's integrated.
Yep.
in it. Oh, that's cool. So this is Teflon. It's a very dense material. I can't call it a plastic, but it kind of is like a plastic, and it's known for being a very inert material. But that's got to be, you can kind of see it right here. Now I've machined stuff at home, and I stay away from a lot of these lighter plastics because of that. Metals are easy to use. Steel is much easier to machine than plastic. So what about that process? That must have been a nightmare.
So it's all a part of the learning curve. But again, that's the benefit of having engineering in-house. So when they're manufacturing and we have a new material or a new application, a new product, they can come to engineering and say, hey, how do we make this work, right? And so if we don't know, we can figure it out.
So I know CNC machines are rated on the number of axes, which means you can see one axis is moving this way, one of them's this way, and one of the axes is this way. But there's a fourth axis because you guys have a rotary. How many axes is this machine? This is CMX 1100V.
Right, this is the 4-axis machine. So you get the X, Y, Z and rotation.
You can see up here, these are all the tools, and they're on a rotary, and it selects the tools, and we've seen it do a tool change. So it requires no user intervention whatsoever. It's programmed in that it knows it needs this tool first, this tool second, this tool third. You can see it does one machining process, and then it'll switch tools. And that's a chamfer bit, it looks like. Yep. Very cool. So you guys kind of just set it and forget it. It loads the parts, or do you have to load the parts?
We have to load the parts.
Okay.
That's done manually.
So that's the only thing that you have to do on this one. But you do have some automatic machines that just, you put in the quantity to make and it just does it.
That's right. Especially the Swiss lathe.
Okay. That's so cool. Now this is a neat material. What are these for?
So that's a Delrin material that's made for a specific subassembly. That's going to go inside of another product,
Okay.
just like the,
It feels really tough. It almost feels like aluminum. It's extremely dense. I'd imagine Delrin is probably a blessing to a machine.
It does make it easier to machine and get those nice
cool.
quality finishes.
We can actually see what it looks like here because it's got a viewing window. So the
And
liquid.
so this is our 5-axis machine,
Okay.
allowing us to do one extra dimension.
Yes, the table can tilt and
You
it can
tilt and
rotate.
rotate, right.
Very cool. So that's coolant that you see, the liquid that's spraying all over the place. And you
That
see,
keeps the chips out of the tool.
you know, it's crazy as you would think that this would be a very dirty environment, but it stays amazingly clean in here because it's all contained inside these machines. Neat stuff. And CNC stands for computer numerical control. So it's basically just math, and the machine uses mathematics to go left, right, up, down, and tilt. Very cool.
So, you know, I mentioned going overkill with the machines, but again, what this allows us to do is make parts of any size that we need for whether it's a biomedical product or for other industries as well.
So you guys mentioned earlier that let's say you get a surge order of 400 units. I mean, you might not have all those parts on hand.
That's
So
right.
you just go into like an old library and just make some more.
We just make more.
That's crazy.
That's the benefit of having it in-house. We don't have to wait for anyone else.
That's very cool. So so I know that this one here, just based on the shape, this is a bar feeder. So it automatically inserts it for every part. And that's a lathe.
So this one's making threaded rods for us.
Oh, cool. I can see why you'd need to do that. So it does all the threading.
We buy the thread stock.
Okay.
It's a stock material. We'll cut it to length and put the chamfers and ends on it that we
I
need.
can see it because you'd have to have custom lengths.
Right.
Yeah. That would be very expensive to do normally. Oh, so cool.
Yeah, that's the raw
Okay.
bar stock.
You guys, that would be very precise, the consistency of the thread. So it feeds it in, and it'll machine the ends, and it makes it to a very specific length. Very cool. Lathes are cool. They're also some of the most dangerous machines. Now, this one's cool. I can hear this one moving.
Yes, and this next one is our Swiss lathe. So we can load a whole lot of bar stock in this one.
Oh, really?
And it can feed itself for hours and hours and hours. It'll pull in the material. It can process on, there's two sets of hands that it can work with. It can work on one side and then pass it off to the other side.
Oh,
and
cool.
machine on the back side.
All right.
So there's literally no touching of the material at all from when you load it to when the parts pop out in the bin.
Neat stuff. And this would be the parts hopper, so it kicks it out.
That's a guy down for me.
Yeah, that's cool. The fact that you guys maintain your stuff, that's another piece of the puzzle that everybody has to understand.
Right. We saw the chips. We saw the, there's a lot of material that has to be extracted from the machine and clean them out, make sure they're oiled and working properly every day.
So just like medical maintenance, you have your own in-house team that constantly maintains your own equipment. You have regular PMs that you
That's
do.
correct. Yep.
And that's wild. And you have to keep track of all that because also you guys are ISO certified. You have
We
steps and
get
processes.
inspected. When was the last time this machine was
Calibrated. so,
calibrated?
yep.
When was it maintained? We have to keep records of that, and we get audited every year.
That's wild. All right. So everyone, in a nutshell, that is manufacturing in the United States. And that's crazy, the fact that they've created all these processes in place and they do everything in-house as much as possible. And that way there they can control the quality,
That's right.
the quantity, and also, let's say they have this crazy idea in the middle of the night and they want to produce something. They can do that too, which I think is even crazier because the normal process is that you have a concept, you outsource, and it's very expensive. You have a
And
minimum
delays.
quantity, yeah, and obviously if you outsource to Asia, you can't control logistics and you can't control the quality. It is what it is when you get it in. So that's amazing. So BC Group, manufacturing in the United States, there's 90 some families of the local community that these guys support by doing this and all these different professions. So you got technicians, you got electricians, you've got design engineers, you've got machinists, all in one spot. So that's an entire community that they support by having an American-owned business. So good stuff, man.
And that's what you'll see on our products too. We're very proud to be able to put on our overlays made in the USA.
Very cool. All right, guys. Well, thanks for watching. That's a walkthrough of manufacturing at the BC Group. Hope you guys enjoy it. Leave comments down below if you have any questions about what you've seen. I know I had a hell of a lot of questions when I first went through here because there's no way that they fit all this in one building, but they did. So thanks for watching, guys.
If you enjoyed this video, don't forget to give it a thumbs up and subscribe for more content. I'd love to hear your thoughts, so drop a comment below with what you'd like to see in future videos.